Right, good day and welcome to this lesson. So today we are going to look at the logarithms. Alright, so I've made these notes very simple for everyone to understand it. Yeah, and as you can see, mathematics or math is easy to learn with. Yeah, chemist Matusu, which is Shakalu. Yeah. Alright, so let's move on to today's lesson. Logarithm notes. Alright. So here I'll read it to you and then explain everything. The note itself is explanatory. Okay, so whenever you see any expression of the form log AB, this means the logarithm of B to the base of what? A. So if you see anything like log B and then you have anything at the base here, just read it as logarithm of B to the base of what? A. Alright, so logarithm was introduced just to explain or solve further solutions in exponential equations, and it's true. For instance, thus giving 3 to the power or 3 exponent x equals 8. In solving this, we know from our basic indices that we need to make this has a base of 3, but we see 8 cannot be what change easily, right? For instance, as you can see at this, we see that it is not easy to express 8 to have a base of 3. So then we bring in our logarithms, that is taking the antilog of that. Okay, so whenever you have logarithm of b to the base of a to solve, first set the given logarithm, right, to be equal to a certain odd variable. Here variable could be any alphabet, can take A, B or any of the alphabets to represent or that particular variable. So that is, we set this given logarithm here, which is the logarithm of B to the base of A, to be equal to Y. Alright, now since A is the base, we know already that A is the base here. Alright, so since A is the base, A will carry Y and leave B standing out alone. So that's it. This implies that we get an exponential equation of the form b is equal to a to the power of y. That is, this a is going to carry out the y, making a to the power y, and then the log will get away and then b will stand alone. Alright, and from here we can see that b is equal to a to the power y looks similar to the 3 to the power x equals 8. And it is true, if we compare this and that, we can see that this a is equal to 3 here, and then our y is equal to what? X here. Alright, and b is representing what? 8. So it looks similar. It means that whenever you have logarithm of that hot nature, just make sure that after you have let that logarithm to be equal to any of the variables, the base will carry 8, and then you can proceed by solving your logarithm. So this is how we use to find out the logarithm of b to the base of what? A. It's so simple. Okay, so let's continue with what I have here. Alright, so now let's consider this example. Let's find the value of logarithm of 32 to the base of 2. From our understanding now, we can see that 2 is the base. 2 is the base here, but this is the base. Alright, and there is the number of the logarithm. So we set this logarithm, the logarithm of 32 to the base of a, to be equal to x, where x is the variable. Alright, that is the variable that we have chosen. You can choose any other variable, say b, a, any alphabet. Alright, and since 2 is the base, it will carry what? X. Alright, so this 2 is going to carry this x, and then 32 will stand what? Alone. Alright, so this implies the logarithm of 32 to the base of 2 is equal to x, implies that this 2 will carry this, so 2 to the power x, which is equal to 32. Alright, so from now we can see what we have obtained is an exponential equation. So now we have obtained an exponential equation. So we change 32 to have a base of 2. Because it is an exponential equation, we need to have the same basis here. Alright, and that is 2 raised to the power of 5, or 2 to the power 5. That means 2 is multiplying itself 5 times. Alright, so 2 is multiplying itself 2 times 2 times 2 times 2 up to what? 5. Alright, so here that is 2 to the power 5. So it means that 2 to the power x here is now equal to, this 32 has been expressed as 2 to the power 5. Alright, so since the bases are equal, it means that the powers are also what? Equal. Hence x is equal to 5. But the exponents are also equal. Remember, in equation, that when we talk about equation, that whatever is on the left hand side must be equal to whatever is on the right hand side. So if we have 2 here, 2 here, definitely the powers are also what? Equal. So we have x is equal to what? 5. So x is equal to 5 is the solution of logarithm of 32 to the base of 8 to the base of 2. Alright, and I think we are getting the actual understanding of it. So let's move on to example 2 based on what we have done so far. Now in example 2, we have to take the logarithm of 27 to the base of 9. So the first thing is to let this logarithm to be equal to b. So remember, 9 is the base, so now we'll carry b. So to get 9 to the power b, which is equal to 27, which will stand alone here. So we change all these values to have a same what? Base. Remember, 9, we have 3 to the power 2, and this is 3 to the power 3. So 3 to the power 2 raised to the power what? B. Remember, in indices, when you raise a power to a power, we multiply the powers. Alright, so we have 2 times b, which is 2b, is equal to 3 to the power 3. Alright, this implies that if 3 is equal to 3, then the powers are also what? Equal. So 2b will be also equal to 3. Then b will give us 3 over 2. That's dividing through by 2. Alright, so now let's move on to the laws of logarithm. From this basic understanding, let's move on to the laws of logarithm. Alright, so laws of logarithm. Remember, this is a live tutorial from Shakalu, which is chemist Matusu. Alright, so mathematics made easy. It's very, very easy, so simple. Okay, so we move on. Laws of logarithm. Now there are 3 basic laws of logarithm of which we are to take notes. They are all based on the operations in mathematics. That's the basic operations: addition, subtraction, division, and what? Multiplication. So without wasting my time, let's move on to the first law. Now the first law states that whenever we are adding the logarithm of the same base, we multiply the numbers of the logarithm. That is giving the log of b to the base of a plus log of c to the base of a. Take note, they all have the same base, and we are adding them. So if such logarithm occurs, then we have to multiply the logarithm of the numbers, that is b and what c. Then we take the base, which is a. So this will give us the logarithm of b times c to the base of what? A. So simple. Alright, so we see that those two logarithms has a base of what? A. Hence multiply b and c to the base of what? A, as illustrated what? Above here. So simple. Alright, so example, if we have the logarithm of 4 to the base of 3 plus the logarithm of 5 to the base of 3, which is equal to the logarithm, because they are all having the base of 3, we multiply 4 and 5, right? So we have logarithm of 4 times 5 to the base of 3, so we get logarithm of 20 to the base of what? 3. So that's the simple simplification of it. Okay, so here you can be given, let's say, the logarithm of what? 12 to the base of 3, and then they give conditions like if the logarithm of 3 to the base of 3 is equal to 1 and logarithm of 4 to the base of 3 is equal to 1.2619, then they ask you to evaluate the given what? Logarithm. Like evaluate this if this equal to that and that equal to this. Right, so they are just testing your knowledge based on your understanding on the first law, right? Whether, so here you express 12 in terms of 3 and then 4, and we can only do that when we multiply 4 by what? 3. So it means that the log of 12 to the base of 3 now becomes the log of 3 times 4 to the base of 3. And remember, we are having times here, multiplication here, so they will turn to addition, right? So here we are now going to have the logarithm of 4 to the base of 3 plus the logarithm of 3 to the base of 3. Then you substitute in the values given to get what? Your answer for it. Okay. So now let's see. Let's move on. Alright. So from the given condition, the logarithm of 4 to the base of 3 is equal to 1.2619, and the logarithm of 3 to the base of 3 is equal to 1. Hence, the logarithm of 4 times 3 to the base of 3 will be equal to, when we substitute in this, we get 2.2619. Alright, so that is the first law of logarithm. Alright, so we move on to the second law of logarithm. So this second law states that when we also divide two logarithms of the same base, we subtract the denominator from the numerator. That is, log of x over y to the base of a is equal to the log of x to the base of a minus the log of y to the base of what? A. Remember, we subtract the denominator from what? That of the numerator. Don't subtract the numerator from the denominator, because subtraction is not commutative. Alright, so we always subtract the denominator from what? The numerator. Simple as that. So example is giving the logarithm of 5 over 2 to the base of 2. This will give us the logarithm of what? 5 to the base of 2 minus the logarithm of 2 to the base of 2. Simple as that. So in any exams, if a condition is what? Given as, say, let's say the logarithm of 2 to the base of 10 is equal to 0.3010, the logarithm of 5 to the base of 10 is equal to 0.6990, and the logarithm of 7 to the base of 10 is equal to 0.84845. Alright, and you are asked to evaluate the logarithm of 35 to the base of 10. Here you don't need to worry much because we try and then simplify 35 as 5 times or 7, because we know that 35 is 5 times 7, so the logarithm of 35 to the base of 10 will be equal to the logarithm of 7 times 5 to the base of 10. So apply the first law that we used because we have multiplication here. Alright, also if you have the logarithm of 50 to the base of 10 minus the logarithm of 40 to the base of 10, which is equal to the logarithm of 50 over 40 to the base of 10, from the second law we get the logarithm of what? 5 over 4 to the base of 10. So you know that 0 cancels 0 here. Alright, so this one is expressed from the second law as the logarithm of 5 to the base of 10 minus the logarithm of 4 to the base of 10. And from the given conditions, you substitute in those values. Remember here I didn't give the value for the logarithm of 4 to the base of 10, so you substitute it in it. So you substitute in the values to get the answer. So on this note, I will end the first lecture on logarithm here, but we need to take home an assignment. So these are the given assignments on board. Alright, so on the next video I will solve these assignments, but before that try it at home and then try your hands on it and see how you get it. Alright, so thank you for watching today's short video. Alright, and then don't forget to subscribe to this video channel for more videos. Thank you. Bye.